all polynomial functions are continuous everywhere. So if it's polynomial, your work is done. Okay. Continuity. That's what today's lecture is about. Ways that we know it graphically, draw it without lifting your pen, if we can see it. If we can't, we graph it, we think it is, we still have to get into those 3 conditions for continuity. Those are on the first page of these notes, so be sure that you are looking at those. Okay. Find a constant. Now, when we say find a constant A, this is not the article A, this is a variable A. So find a value for the variable A such that this piecewise defined function is continuous everywhere. Okay? What you think about that? Make sure that you know what we're talking about. We're going to replace A with a value so that this is continuous everywhere. Now, this piece down here, what do you think about it? Horizontal line, polynomial function, continuous everywhere. But what is the graph indicated with this piece of the function? A line? It says that when x has a value of A, the output value is 8. Not an asymptote. When x has a value of A, the output value is 8. It's just a simple point. That's all this piece is just a simple point. Okay, so we'll kind of keep that in mind as we go through this. Okay, g of x equals. We're going to look at this piece up here. Now what we are able to do at times is remove the discontinuity. We did this when we had limits. We could rewrite the function so that the problem no longer existed, except that we knew that we had to put a hole in the graph. Remember those problems we did? Go back and check them if you're not too sure. Well, we're going to do this again. On this piece right here, is there any way that we can take this function and rewrite it? Yeah. X squared minus A squared? X minus A, X plus A, divided by X minus A. We could rewrite that. And we've got an X minus, not that. Okay. We'll take the correct one here. Okay. We have the X minus A's that cancel. And now this piece is simply X plus A. Nice little polynomial function. Continuous everywhere. However, what we have now is a situation where this is going to be a nice line that's going to have a hole in the graph. It's going to have a hole in the graph exactly where x is equal to a. So it's going to be like this. Well, let me see if I can make it clearer by changing pens. It's going to be like this. It's going to come up here, and it's going to have a hole in the graph, and then continue on. It's supposed to be a line. Imagine that to be a line. Now, that hole that's created with this graph right here is plugged by what? The hole created by this graph is going to be filled in by what? By this one, yeah. Okay? So, we have an idea what's going to happen, and now all we have to do is to figure out, well, what exactly is going to be the value of A that creates this really nice piece so that eventually this function g of x, once we plug that hole, we fill that hole in, is actually going to be a nice continuous line. The hole we had from the first piece is filled in by the second piece. Okay, so we need to go down through this and see, well, what can we possibly put in to the value A to make that work? Well, let's see. What we have is that x squared minus a squared divided by x minus a. If this happens, then this piece of it has to have the same value as 8. You know, it's time to go. We're going to come back to this problem. It'd be a good place to pick it up on Tuesday and finish this. So we're going to save it at this point. I want you to think about this problem, and we'll come back and see what you finished up on it.